Hi guys and gals. I've had several of you request that you see some more examples of manometer problems so you can finish your homework. So I'm going to do question number 5 from the harder sheet, the 11-2, one you are not assigned, but one that should be fairly similar to some of the other ones that you will be seeing. So the first thing that I need to do is come up with an equation that describes what's going on here. And so what I'm going to be doing is looking at my manometer and seeing, okay, well, how does the air pressure compare with the gas bulb pressure? And I can do that by checking where the mercury is inside the manometer. When I do this, I look and I see that the push for the push of war is favoring the air pressure. It is pushing the mercury up higher onto the bulb side, meaning that the air pressure is greater than the pressure inside the bulb. This being the case, that means now that I am going to use my equation that describes this case, which means that I'm going to be subtracting the height of our mercury column from the atmospheric pressure in order to find the gas bulb pressure. So I have an equation, but I notice that I must use the unit millimeters of mercury for my final answer. This height is in millimeters of mercury, but this gas bulb pressure is not. So we need to make sure that we have both the gas bulb pressure and the height in the same unit as what our answer wants to be. So we're going to have to do a conversion before we can use this equation so that we can make sure that this is millimeters of mercury. So let's do that next. So what I've done here now is I have placed a conversion factor for converting my kilopascals into millimeters of mercury. I'm now going to use those conversion values that I gave you, and I'm going to plug in the 760 for the millimeters of mercury and the 101.3 for the kPa. The reason the kPa again is in the denominator is so that it cancels and leaves us just the millimeters of mercury. When we plug this into our calculator, we get a conversion factor of 653 millimeters of mercury. So what this means is this value here for our gas pressure is, in millimeters of mercury, 653. We can now plug these values into our equation that we have up here, and everything's in millimeters of mercury, so it should solve out correctly. So let's go ahead and do that. I've now plugged in the values for each of these things. So my gas pressure, we just calculated at 653 millimeters of mercury. My atmospheric pressure is what I want to know, and my height of my column is 155 millimeters of mercury. So to solve correctly for atmospheric pressure, I need to get rid of this height column value and bring it over to the other side. In order to do that, I'm going to have to add that value to 653 to get the correct answer. Here I've done exactly that. I plugged in the values and I've gotten the atmospheric pressure as 808 millimeters of mercury. So what that means is this is my actual answer here, 808 millimeters of mercury. That is the X value right there. Hopefully this helps you do your problems tonight. If not, we will work on them again a little bit tomorrow. I hope that you have success with this. Over and out.